write to draw like different structures of the isomers of propane. Propane does not have any isomers, right? Because it's only three and it can't be branched. It has only three carbons.
Yes.
So that's right. Because I tried in formulas and I couldn't find an isomer for propane.
For propane.
Yes, propane.
Only for propane? Was there anything attached to propane?
No, just propane. C3H8.
Okay, only propane. Okay, let's see how propane can be written down. Okay, propane. Propane is C3H6, right?
Not propane. Propane. C3H8.
H8. Right?
Yes.
Okay, so one is that means this can be written down as CH2 CH CH2, right? I don't think so. I would have given you propane. Is it correct? Because this structure, however we form, we will be getting this only. So
yes,
this only.
you did. I just wanted to make sure I know. Isn't it CH2, CH3, CH2?
This one, right?
I mean, it's CH3, CH2, CH3.
Sorry, can you tell me once again? CH3?
Yes, CH2, CH3.
Sorry, yeah. CH2, CH3, yes.
Okay. So propane is an exception, it has no isomer.
Yes. Only because, yeah, we cannot do anything with this because since it has only three structures like a triangle, no matter what shape we form, we'll be still having this triangle only, right? If
Yes.
we have something called butane where we have carbon as 4, we can put it into any shape like this. I mean, if structural I'm talking about, right? We have different shapes when we are talking about four-sided figure. But when you're talking about three-sided figure, it is always a triangle over here. Okay?
Yes.
Okay, fine. So shall we start with alkenes for now?
Yes.
Okay, good. Okay, again, we saw organic chemistry, they belong to homologous series. Now, what is a homologous series? Alkenes are also a part of a homologous series. What do you understand by homologous series?
They belong to the same functional group and they have the same chemical properties.
Very good. They have same functional group and similar chemical properties. Okay. So alkanes, they belong to the homologous series of hydrocarbons. What are hydrocarbons?
Hydrocarbons are elements of hydrogen and carbon.
A compound that contains only hydrogen and carbon. Okay. So alkanes, they are a homologous series of hydrocarbons. Okay, and we saw that they will be having the same functional group and similar chemical properties. Now, if we increase the chain length, what will happen? Their boiling point also increases. That means if I increase my if we increase number of carbon atoms, if we increase carbon atoms, then naturally hydrogen atoms will also increase, right? When they increase, what is happening? Their boiling point also increases. Okay, and the general formula for alkanes. General formula for alkanes is CnH2n plus 2. Okay, this is the general formula of alkanes. Now this general formula means that the number of hydrogen atoms in this alkane is double the number of carbon atom. Am I right? Number of hydrogen atom is double the number of carbon atom. We'll see with an example. If methane, okay, in methane, no, let us put the value of n equal to 1. So my formula will be CH, 2 times 1 is 2, plus 2 will give me 4, right? If my value n is equal to 2, so C n will be 2, H will be 2 times 2 is 4, 4 plus 2 is 6. So this is methane, this is ethane. Okay, so this is about the general formula. Then this alkane molecule, what we are talking about, this alkane molecule, they can be represented by displayed formula in which the atom will be shown by a symbol of C and H, and there is a covalent bond formed between them. Covalent bond formed by a straight line. Okay.
Yes.
Now we'll be seeing few names and few structures of the 5 most common or the 5 first alkanes. Okay. First one, a compound when n is equal to 1, what do we get is methane. So the name is methane. Molecular formula is CH4. Structural formula will be CH, H, H, H. And if we need to draw a ball and stick model, it will be this way. Okay, this is the way a ball and stick model will be. Second is ethane with the formula C2H6. Structural formula will be CC. So that is ethane. Tell me once you're done, then I'll move on to the next slide.
I finished.
Finish?
Yes.
So we saw ethane. Next is propane C3H8. Structure will be 1, 2, 3. That is propane. Next coming to butane. So we saw structures of methane, ethane, propane, butane and pentane.
I finished drawing them.
You finish?
Yes.
Now, alkanes. Alkanes, they are all saturated hydrocarbons. Okay. They are all saturated hydrocarbons. What do you mean by saturated hydrocarbons?
I'm not sure.
Saturated hydrocarbons means their carbon atoms, they are all joined to each other by single bond. You see, everything is joined by a single bond. Okay, the
Yes.
carbon atoms are joined by single bonds, and because they are saturated carbohydrate hydrocarbons, what happens is they make them relatively unreactive. Alkanes are unreactive. Okay, they are reactive only with oxygen, which we call as combustion. Okay, most of them are unreactive except for oxygen, which is termed as combustion. Clear? And like with all other homologous series, alkanes, they show isomerism. Here we have just seen one of the structural form, but we will have many isomerism. Okay? Now, isomerism, I'll just tell you one example. Are you done with this page?
Yes.
Okay, moving on to the next page. They show isomerism. Let's see one example. If I had to do butane, so the formula for butane is
C4H10.
H10, right? Now generally if I had to write C4H10, I can write it as CH3, CH2, CH2, CH3, right? This is my general butane. Now if I need to put an isomerism to it, there are many ways. One example we can see is CH3, CH3, CH3. Okay, this is one isomerism of butane, and it is nothing but methyl propane. Okay.
Yes.
Now can you try for butane? Can you try for pentane?
Is it a 2-methyl propane?
Okay, we can put that way also. This is methyl propane in general. You can also put as 2-methyl propane. This is also acceptable. This is also acceptable. Pentane will be C5H.
12.
Yes. So have a try with this pentane. Can you tell me how many isomers can be formed with the help of pentane?
Is it 4?
Can you put it on the board if possible?
Yeah. That's 1.
Okay, this is 1. So how will you name this compound?
It's 2-methyl butane.
2-methyl butane. Okay.
Because in already see 0 1 2 3 4 5 6 7 0 1 2 3 4 5 this is much. We are not using this these days, right? See what I wrote. See what I wrote inside this one. We didn't see. I want to see. See now.
Nice.
Miss, how will they look like when they're combusted?
Sorry?
How will they look like when the combustion happens?
Combustion?
Yes.
No, we'll see that. Okay, you told me only one of the pentane. There are many more isomers which you still can form. So can you form one more isomer? Just one more isomer and then we'll go ahead with the reactions.
Is that right?
Okay, this is right. So what will be the name of this compound over here?
Is it 2-dimethyl propane?
If it is 2-dimethyl, you have written a single ethyl compound, right? If it is
Yeah.
okay, if it is dimethyl, that means you have to put one methyl over here and one methyl over here. Okay, that way it will become methyl. Okay, since you have given a compound wherein it is again attached to this way, either you can name it as a propane, right, because 3 carbon atoms, so it will be 2-ethyl propane, or if you had to name it this way, it will be 2-methyl butane, right?
Yes.
Okay. Shall I move on to the next slide?
Yes.
Okay. So these were the isomerism, the nomenclature which we saw in alkanes. Okay. Next, what are we going to see is the substitution reactions in alkanes. Now, the word substitution. What do you understand by the word substitution?
Just a compound that substitutes like a C or an H in the hydrocarbon.
Okay. Substitutes in the sense means they are just replaced, right? Where one of the atom is being replaced with another. Now, why we are talking about substitution reactions here is because they are very useful reactions in chemical industries. Okay, they are widely used in chemical industries because what happens is they allow the chemist to change one compound to another compound. Okay, now alkanes, they undergo a substitution reaction with halogens. Okay, with halogens, and with halogens what do they do is they undergo this substitution reaction in presence of UV light. Okay, in presence of UV light they undergo substitution reaction. We'll see one example. Okay, so when I react methane with the bromine, what I get is methyl bromine and hydrogen bromide. How can I put it in formulae? CH4 plus Br2 giving me CH3Br plus HBr. Okay, you understood what is happening here? Substitution. What do you understand by substitution? Here, if you see, we have 4 hydrogen atom, right? Plus 2 bromine atom. What happens is one of the hydrogen is replaced with one of the bromine. Okay, and hence we form is CH3 Br plus HBr. You understand what is happening here? Okay. This hydrogen bromide, they form a separate compound, and the one which is left over is taken by the methyl group over here. You understood this part?
How is the CH3Br? Why is it CH2Br?
Which one?
For the methyl bromine. Don't. Oh, no, never mind. I got it. But only one of the BRs are replaced with
Yes,
one
only one of the
CH2.
only one of the bromine is replaced. Okay, because there are two bromine atoms, right? Bromine is diatomic in nature, so two bromine is there. So we are, what is happening is one is going to substitute. So this, if I'm taking these two, they join together, and this bromine is going to substitute in the place of this hydrogen. Okay, now you tell me, what will I get if I react ethane with chlorine?
You will get, is it ethyl chlorine?
Ethyl chlorine
And hydrochloric acid, HCl.
hydrochloric acid. Okay, how will you put it in the formula form?
C2H7 plus Cl2
C2H6 plus Cl2
Cl2 gives C2H5Cl plus HCl.
Is it balanced? Is it perfect?
Yes.
Yes. So you understood
Yes.
how chemical reaction with halogen is happening?
Yes.
Okay. Shall we move ahead?
Yes.
Now what did we see? That alkanes, they are generally unreactive except for combustion purpose, right?
Yes.
Okay. So we will see how combustion of alkanes is taking place. combustion. What do you mean by the word combustion?
It's the adding of oxygen.
Sorry?
It's the adding of oxygen.
Combustion is adding of oxygen. Okay, what happens exactly in combustion?
I'm not sure.
Not sure?
No.
Okay. We'll put the formula first, okay? If suppose I am reacting, no, I'm just reacting methane plus oxygen, okay? What am I getting is carbon dioxide plus water. Methyl, when reacted with oxygen, gives me carbon dioxide and water. You understood what is happening with combustion?
Yes.
Whenever we are reacting any kind of a compound with oxygen, what we get as the end product is a carbon dioxide along with water. Just check and see whether it is balanced or not. Okay, tell me what, first balance this one and then I'll tell you.
There's a 2 in front of the oxygen and a 2 in front of the water.
2 in front of oxygen and 2 in front of hydrogen. Okay, do the next one. C8H18.
Is it a 2 in front of the octane?
2
In front of the octane?
here.
Yes.
Okay.
25 in front of the oxygen?
5.
25.
25.
Yes.
Okay.
And 16 in front of the carbon dioxide?
Okay.
and 18 in front of the water.
So this is a very big number, right? What we'll do is divide the entire thing by 2. What do you get then?
So, there's nothing in front of the C8H18.
Okay, so that means
And
C8H18. 25. The half of 25 will be
12.5
12.5. Okay. Oxygen giving me 8 CO2 plus 9
and
H2O.
H2O.
Okay, clear with this part?
Yes.
Combustion. Combustion means burning. Combustion means burning. Only when we burn, we will be getting carbon dioxide. Okay, as I was telling you, combustion means burning. Now, the burning of fossil fuels such as alkanes, they provide the society with environmental problems. What happens when we burn alkanes? Okay, you understood what is combustion? It's just burning over here. Then we saw substitution of alkenes. Okay. Okay, I'll give you few questions to write. Just let's see how we can solve it. These are the questions.
This for the conditions of the substitution reaction. Is it only UV light or is there anything else?
Only UV light, that is it.
I'll give you a letter. This one is that.
I don't understand C.
What is a formula of two possible mono substituted products? Okay. Substituted products. We're talking about substitution, right? You can write any kind of substitution products you will be getting. It's like when we were talking about substitution, what did we got was methyl bromine for the formula CH3Br, right? For ethyl chlorine, like that you can write. Other than these two chemicals, these two compounds, you can write any other names.
Miss, can you go back to the question, please?
Oh, sorry.
Yes, I still don't understand. Like, I understand, but I don't know how to name it.
Okay, see, one thing which we saw earlier was methyl bromide, right? Then we saw was ethyl chlorine, something we saw like this, right? Now, other than this, you can put any compound. We saw methyl, we saw ethyl. You can put a propyl, butyl, pentyl, anything with one of the halogen. That's it.
Oh, here they're asking about butane and chlorine. So do I put butyl chlorine?
Okay, the question says butane reacts with chlorine, right?
Yes.
Okay, then if they're talking about only butane, butane has four carbon atoms, right? And chlorine. Now chlorine, you can place chlorine in any of the carbon, right? We will be having different isomers over here. So you can put this chlorine anywhere. Try to put over here. Then what will be the name of this one? If the same chlorine is put over here, what is the name here? If the same chlorine is put over here, what is the name here? That way. So they need two isomers.
Yeah, I understand, but I don't like if the chlorine is on the second carbon, how do I name it?
If it is on the second carbon, it will be,
Yes.
you just put the structural formula. They have not asked the written the name, right? Just put the structural formula like CH2, CH2,
Oh
okay, CH3, CH2, CH, like that. Put only the structure.
yeah.
Finished?
Yes.
Okay, so what will be the answer for the first one? Of butane.
It's yes, it's C4H10 plus
C4H10
plus 6.5 O2
oxygen
gives 4 CO2
okay
and 5 H2O.
okay, very good. Next one, butane reacts with chlorine in a substitution reaction. What conditions are essential for this reaction?
UV light.
UV light, okay. Third one,
For B, it's substitution reaction for butane and chlorine. It's C4H10
equation for this reaction, okay. C4H10
plus Cl2
okay
gives C4H9Cl
gives C4H9Cl plus HCl.
HCl.
Okay, right. Then we saw the two isomers. What is the answer for the last one? What is the formula for the final product obtained from the complete substitution?
It's butyl chlorine. Is it?
It will be C4H10, right?
Yeah.
Okay, so these were the answers. You're clear with what we have done with alkanes?
Yes.
Yes? Okay, now I
Yes, everything's good.
sorry. Okay, we have
Understand everything, yes.
yes, okay. So we have done on alkenes for today. Okay, next class we'll see is about
Yes.
alkenes. Yeah.
Okay.
Okay. Shall we conclude up here?
Yes.
Thank you.
Thank you.
Thank you.